Hello, everyone. I hope I'm audible. Can someone please confirm in the am I audible? Hello. Can someone please confirm if I'm audible or not? Okay. So let me share my screen. So again, there's a Menti QR. You can scan this QR and join so that you can ask your doubts here. You can use the QR or you can go to menti.com and write this code. Okay. In the meanwhile, you can join using this QR and you can ask your questions here or in the Zoom, or you can always unmute yourself. So let's uh, start where we left off. So we left at the error detection part. So we were looking at the parity magic in which we were seeing this table. So let me draw this once again. So this was the table which was given to us, and we were so player one will come and he has some coins with them. So zero if he put it as a tail, and head if it put it as a one. So we, because since we don't can't present it live, so we are saying that he's putting, if he's putting the coin and upside part was a tail, so that we are denoting it by zero, and upside part was one, then we are denoting it by one. So this is kind of the table which player one makes. And then, so what he will do is he will flip one of the coin in the table, and you have to guess which coin does he has flipped in it. So to do this, he is giving you a choice of writing one table of yours. So that is a 4 cross 4 matrix. You can add one more column in this and the row in this. So in that, you're writing a fifth row, and this is just the recap which we did in the last week. So we are writing this column as the sum of the rows which we have given. So that is 1 1, that is 0. The XOR sum of 1 and 1 is 0. So basically number of ones are even, then 0. If the number of ones are odd, then 1. So if the here the number of ones are even, so 0 again, here also 0, and here is 1. It's 0, 1, 0, 0, and again it's 1. So that's how we make the table. And let's see if now he has flipped this coin, this 1. We say this one. So now this one has been become 0 here, which was, I guess I have written there. So okay, 0. Now the table of our table was same, this 1, 1, 1, and it says 0, 1, 0, 0, 1. The table of the rest of the table is same. Now we have to check which is the flipped coin will be. So what we will check? We will check that if the XOR sum of this, like the rest of 4 cross 4 and this are same or not. So this is 1 and 1, which is even, and 0. So this is correct. Now again 1 and 1, which is even, and this is 0. So it's correct. Now 1 and 1 is even, so 0, correct. This is 1 and 1 odd, even, but this is 1. So which is not, should not be the case. So basically this is the XOR column. So this is the bad case. Now same thing we will do it in the g- column wise. So this is 1 and 1, 0, which is good. 1, 1, 1 odd, which is 1 again. This is good. This is 1, but here it's 0. So it's again a bad case. So this is 1 and 1 even, correct, and this is 1 odd, correct. So the intersection of the bad cases will be the edge which has the coin which has been flipped. So this is from 1 here and this is from 0 here. So this must have been flipped, and this is actually the coin which is have been flipped. So this is the thing which we did earlier, and then we thought of then we look at the impossible prison break, in which the so these are like kind of a doors, different doors which they have written down 0, 1, 0 as like presented it, and in one of them they have put a, so this is like we have placed these like prisoner has placed these coins like this. Now he has, in behind the doors he has flipped, he has put on a key behind them. So sorry, the police has been put a coin behind the door, and the prisoner wants to find that key. So he has given you this 4 cross 4 table of these coins, in which again 0 is represented as tail and 1 is represented as head. And has 16 doors, in which one of them behind he has flipped the coin, flipped the key. So now, so there are two prisoners. So prisoner 1 will go and just flip one coin, and then the prisoner 2 will come, and by looking at the table he have to find it in which door behind the key is there. So prisoner 1 knows where the key is there, and prisoner 2 doesn't. Now for example, so to encode this code, what we did is, which as we have looked in the last week as well, so we have assigned these numbers, these boxes, basically these 4 cross 4 table as the door. So this is 0th door, this is first door, this is second door, this is third door, and so on. This is fourth door, this is fifth, and all. So this is 15th door. So this how we have presented the doors. Now we some need some communication between prisoner 1 and prisoner 2. So they have communicated like, if the first, so you can always write 16 number as in the 4 bits in the binary. So in, to get which bit is this, like let's say in this case what the this whole table represent, which bit, which 4 bit. So the first bit with which they have decided is that the last two rows will be there, the XOR sum of the last two rows will be their first bit. So in this case, if we look at the last two rows, these are 4 ones and this 5 ones. So this is that number of ones are odd, so it should be 1. So the first bit should be like 1. Second bit is second row and the last row. So if we calculate look at second one, last row, it will be 2 and 1, 3, which is odd again, so it should be again 1. And if you look at the third bit, it will be the last two columns, so it will be 2 and 3, 4, 5, again odd, so again 1. And if you look at the latest second column in the fourth column, so 2 and 3 again, 5 again 5. So this represents 1, 1, 1, 1, which is, if we see in the decimal, it will be 15. So the key is behind the 15th row. So prisoner 1 is telling the prisoner 2 is it is behind 15. But if it is not behind 15, then if let's say it is behind some way, so this is the proper table which I have written. Okay, let's say you want to hide the key at the seventh cell. Let's say, so the key is behind seventh cell, and from this table you want to tell that where to prisoner 2, that where the key was hiding. So now this we have seen that this represents 15 to us. That means the bit which we gave is 111. Now prisoner 1 has the option to flip a coin in between them. So first we will see that what we can write 7 in the binary. So 7 we can write in the binary as 0111. So now currently the key shows that it is 15, but we want to target to show it 7111. So only change is like one second bit is same, third bit is same, fourth bit is same. The only change was in the first bit. So if you look at the the first bit represents the last two columns. So the first bit should have been changed in between them, right? That means this and this have been changed. Should be changed. Like one of the coins should be changed, because in this right now there are odd number of ones. So if we flip one coin, then there will be even number of ones, and then that zero sum will give you 0, so the target can give you 0. But in the second bit, in the third bit, and then the fourth bit, it should not be the case. So the first bit should be the change. So these are the possible changes in which we can flip the coin. Okay. But the second, third, and fourth bit should not be changed. So according to the second bit, so according to the sixth bit, the second row and the fourth row should not be changed, because in this case we don't want it to be changed. Right? In this only we need change. So that means these things should not be changed, which we are again not changing because we only want the change in the first bit. And in this case, this bits should not be changed. So if this should not be changed, sorry, this should not be changed. So let's remove this. So by default, we can't change these columns, these coins, sorry. And again, the third bit and the fourth bit similarly, in the third bit, the second, third column and the fourth column should not be changed. So again, that means this and this should not be changed. And if you look at the fourth bit, that shows that the second column and the fourth column should not be changed. So this should not be changed. I'm sorry, I have drawn much more, I guess. This should be it. So let me draw it again. First, I have drawn like 5, but it should be 4. So these are 4. The second bit should not be changed. That means this should not be changed. In the third bit, this should not be changed. This is again a line here. And the fourth bit, this should not be changed. So the only possible change we can do is in this column. And this column represent like top from third, it should be this. So we should flip this coin. So if we flip this coin, this becomes now 0 and all else is same. So let's again verify that are we showing from this table 7 number or not. So the first bit is the last two columns, this and this. Let's source sum this. It will be an even number of ones. So it is giving you a 0. And the second bit is this column and this column. So it will be 1, 1, and 1, which is odd. So 1. And the third bit is this and this column sum. So this is one, two, three, four, five ones. So again one. And fourth bit is this one and this one. So again 1 and 1, 2, 3, 4 and 5. Again 1, 1. This is showing us 0, 1, 1, 1, and this is telling us that this the key is behind this seventh door. Okay, let's take an example and you should answer this whether in Zoom or in the Mentimeter. So anywhere is possible, and if you can unmute yourself again, you can say. So let's say your current is 8. That means the table which is given to you in this is given to you that the it's showing that the key should be at the 8th door, whatever the table is. Let's say it's showing that it's 8 and its binary is 0100, and you have to tell the prisoner 2 that the key is behind the door 14. So first tell what is the binary number of 14. Can you please tell anywhere in the Zoom or in the Mentimeter? What can you write 14 in the binary? And if you haven't joined the Menti, then again you can scan this QR which is in the left side and you can join and answer. Okay, any answers? Like how can you write 14 in the binary number? Like 8 you can write as 0100. Is this Menti working? Mhm. Okay, well, someone said 1110. Okay. Please write in the question Q&A and not in the live chat if possible, because live chat hides after some time and I can't able to see it later on, but it's okay. It's 110. Someone said 1110. Here you can write anything since I can't able to even see who is saying what, so you can not be shy and just write your answers. You can join this by using the QR. I see only 3 people have joined, so it will be better if more people are here. Okay, let's look at the Zoom. Let's show 1110, 1110. Yeah, okay. So let's look at this. So yeah, you guys are right. You can write 14 in the binary as 1110. And now let's the main question. What cell you will flip? So draw the first bit, second bit, third bit, and fourth bit like we did here, and try to find which where the coin you should flip. So in particular, if you see your current cell is 8 and you want to target 14, so you have to change the first bit, second bit is same, and you have to change the third bit. So the first and the third bit need to change, and the second and the fourth should remain same. So which cell you will flip? And these are the 4 bits. Try and think an answer, and yeah, like wait for 5 minutes and see if anybody answers. And then if not, then I will explain. So the question is that we your coin currently table is showing 8, but you want to show your table to 14. Okay, someone said third from the left and second and third from top. Okay, how this is two? Okay, you're saying two choices. Third from the left and second and third from top. So you are saying third from the left. Uh, so third from the left, this one, and second and third, you said, right? Second and third from the top. Okay. So you're saying these two you can flip. Okay. So you're giving two options. Okay. But doesn't this change if you change the second this will change your second bit because this is present in the second bit.
Excuse me, ma'am.
Yes.
Ma'am, it's third and fourth, ma'am.
Third and fourth you're saying.
Yes, ma'am, I
Okay.
mistyped it.
So you're saying this and this?
Yes, ma'am.
Okay, but then if you change these two, this again is the same option. If you change the fourth one, this will change the second bit as well.
Then third one alone.
Yes, the third one alone you're saying. Okay. Okay, let's verify this one. So the change is only in the first bit and the third bit as we have seen. Okay. Yeah, you are correct. So let's again, let for the other people, let's just explain it once again. So you want to change the first and the third bit. So if you want to change the first bit and the third bit, you have to look at the intersection points of these two. So you can't only just change these the left terms and these terms because this will only change either the first bit or the third bit. So if you want to change both the bits, so you have to look at this fourth, these four many because this is the intersection. Now you don't want to change the second bit and the fourth bit. So if you don't want to change the second bit, so this should not be changed. So this is not here even present. But in this case, this should not be changed. So this we have to just remove. And in the fourth bit, you don't have to change the second column and the fourth column. So second column is not there, fourth column, there is this there. So you have to remove. So the only thing you change is this one. Okay. And this in the binary, if you look at the table, this represent 1010, 1010, and if you look in the binary, this is basically the 10th cell. So you have to flip in the 10th cell. I hope this is clear. Let's look. Okay. There's no comments here. Let's look in this one. Here you are. Okay. So if there are no questions, let's look at the week 5 part, which is insertion sort. So insertion sort. Okay. So as the name suggests, you will take an item and insert it where it belongs. So for instance, if I give you I explain this in the form of cards or numbers. So if I give you one card, 9, first card, okay, so it's itself is a sorted card because one card you can't be like decreasing order, increasing order. This is itself a sorted card. Let me give you another number which is 8. So the second card is 8. Now you will look, insert this number 8 where it where it belongs. In the, let's say we are sorting in the ascending order, that means the smallest one is in the first side and then the increasing. So if 8 is the second card, you will insert this card in the left side of 9. So that is 8 and 9. And let me give you another number, let's say 6. Again, this, since this is smaller than 9, this is smaller than 8, then you will insert this number in the again left hand side. So 6, 8, and 9. And if I give you a card now 7, so you will look at 8, it's just smaller than 8, but it is bigger than 6. So you will insert this number in between 6 and 8. So here, 7. Let me give you an example in the form of array. So let's say this is the example. So this is the sequence of the cards which will come. Like in the computer, it shows like this. This is 8, 4, 23, 42, and 16, and 50. So again, you will just look at the first card, which is 8. So it itself is sorted. You don't need to do anything. And the sorted array is again 8, 4, 23, 42, 16, and 15. Now, you will look at the second card, which is 4. But 4 is smaller than 8. So you will swap 4 and 8. So this will become now 4, 8, 23, 42, 16, and 15. Since it is smaller, so you will swap these two. Okay, so in this case, you have, okay, let's do the example first complete. Now, so these are sorted. Now this is your third card, which is shown. Now, if you look at this 23, first you will compare it with 8. Since it is bigger than 23, so you will just keep it there and there is no need to sort it further. So you will just write 4, 8, 23, 42, 16, and 15. Again, if you look at now 42 and you will compare it with 23. So this will again, since it is bigger than 23, so it will remain here and there is no swap in this case. This will be same. Now, if you look at 16, and compare it with 42, it is smaller than 16, so 16 should come here. So you'll swap there and now compare 16 and 23. So 16 is also again smaller than 23, so you will swap again here. But now since 8 is smaller than 16 and 23 is bigger than 16, so 16 will place it here. So this is 16 will be 8 and 23. And so on. You will go like this and complete this array. But we want to find that what will be the worst case to find the, like, you using this algorithm, the insertion sort, how many times, like what is the worst case you will take the time to sort this array now. So you have to sort this, but in the worst case, what time will you take? To do that, we will look at the number of swaps and the number of comparisons. So if we look at this case, when we are looking at 4, so in the first case, let's look at first, we are looking at 8. There is no swap and there is no comparison. So for this, number of comparisons are 0 and number of swaps is 0. And now when we look at 4, we swapped between 8 and 4. So it will now become 4 and 8. So the number of swaps we did is 1, and the comparison is that when we looked at 4 is small, 8 or not. So that is again 1. And if we look at then 23, we compared this number first with 8 and we see that it is greater than 23. So there was no swap in between them. So the number of swaps was 0, and the number of comparison was 1. Okay. So when we look at now this 23 and 42, again, we have seen that 42 is bigger than 23. So there was no swap for this case. So again, the number of swap was 0. And but we compared 23 and 42, so the number of comparisons will be 1. And if we look at 16, so we swapped 16 first between 23 and 42, and then we compare it with 23 and swap between 8 and 23. So the number of swaps was 2, and the comparison we did is first with 42, then 23, and then 8, that is 3. In general, like number of swaps are 1 less than number of comparisons. But so I wanted to ask you, what will be the worst case, like worst thing that we have to compare? Worst array you can give me if I want to arrange my numbers in the increasing order, like 0, 1, 2, 3. So what is the worst array you can give me that it will take a lot of time if I use the technique of insertion sort? Insertion sort is like if I look at one card and then I will sort it, like place it in between them. So that is what we generally do when we play cards or anything. When we sort it like this. We saw the card and then insert in between the card numbers wherever it belongs. So can you tell me the what will be the worst array you can give me in which the number of comparisons are too much and the number of swaps is also too much? Okay, let's look at this. If there are any, so there are no questions, I guess. Here you can ask in the Mentimeter if you have any questions. They're just asking what will be the worst array which can increase the number of comparisons and swaps. Like for example, you have four numbers, 1, 2, 3, 4. So what will be the worst, like what will be the worst permutation you do with this number, that the number of comparisons you have to do with the insertion sort is way high? Okay. Did you understood the question? If not, then I'll explain it with an example. Okay, Sanjeevani, where he said 4, 3, 2, 1. Okay, that is the one permutation you have. Can you try this now? Okay, let's try this 4, 3, 2, 1. And is there any other answer? I think so. No. So let's try 4, 3, and 2, 1. And this, okay. So if you know that if I give you 1, 2, and 3, 4, then there are no comparisons, right? So the first card is 1, you will place it there. The first, second card is, sorry, the comparisons will be, number of comparison are still 4 in this case. This is the least you can do. Like you, first card is 1, and then the card comes 2, you will compare it with 1, it is greater than 1, so you place it in the second index. Then the third card comes 3, you will compare it with 2, it is still higher than 2, so you will keep it here. And fourth card comes, it you will see it with 3, it is greater than 4, you'll keep it here. And this is the order which we again want. Now, so the example which he has given is 4, 3, 2, and 1. Okay, so first card comes 4. So since this is the only card, one card here, then there are no comparisons and no swaps in this case, so this is done. Then 3 will come. 3 card will come. Since 3, the comparison you did is that 3 is less than 4, so rearrange this array to 3 and 4 and swap between 3 and 4. Then the third card comes, which is 2. You will see, compare first 2 with 4, and you'll see that 2 is less than 4. And then you will compare it with 3, so 3 is less than 4. And then you will swap between 2, 3, and 4. So there are two swaps. For this case, you have swapped the 2 between 3, 2, and 4. And then you swapped it to 2, 3, and 4. These are the two swaps you did. Okay. And there are comparisons are 2. These are the 2 comparisons you did. And this is in the 1 comparison you did. So now the fourth card comes. Okay. So now the fourth card comes, which is 1. So till now your sorted array is like 2, 3, 4. So the sorted first comparison was between 4 and 1. So you get 1 is less than 4. You'll swap and it will be like 2, 3, 1, and 4. And then you will compare again 3 and 1. So 3 is greater than 1. And then you will swap 2, 1, 3, 4. And then again you will compare 2 and 1. And then you will swap 1, 2, 3, 4. So this is the sorted array you get. So in this case, the number of comparisons you did. In the first card, when 3 was there, that is the first comparison which you did. In the third card, you will do 1 and 2 comparisons. So that is 1 plus 2. And in this case, you get 3 comparisons. That is 1 plus 2 plus 3, which is 6. And if you look at the even number of swaps, so these are also 1 plus 2 plus 3. The first case you did 1 swap, in the second case you did 2 swaps, and the third case you did 3 swaps. So it is again 6. And you can try any type of permutation of 1, 2, 3, 4, 1, 2, 4, 3, any 16 combinations. So sorry, I guess this is 24 combinations. You will see that the worst case will be this, that number of comparisons you have to do is 6 and the number of swaps you have to do is 6. So yes, you are right about this. So the worst case is when the numbers are arranged in the decreasing order. So look at, let's say we want to, because we want to find the worst case in the case, and we want to find out what will be the number of the worst number of comparisons we have to do. Let's generalize this 1, 2, 3, 4 case to n. So this is type of an array we want. So this is the array which is now given to us, because we know now the worst case is that the larger number is in the first case, in the second and third and fourth, like this. Like this here was in first beginning it was 4, 3, 2, 1. So it's like 4 is largest, 3 is next, 2 is next, and then 1 is next. So in this case it's like this. So let's, in the first step, the first card will come. The card I1 just comes. And in this case, you don't need any comparison and any swap. So this will be just 0 and 0. Then in the second step, I1 and I2 comes. So you will compare between them I1 and I2. And since I1 is greater than I2, you know this. So you will put I2, swap between I2 and I1. So the comparisons and swap was again 1 and 1. So now if we look at 3, it will be, now the sorted arrays was I2 and I1, and the third array which comes is I3. So I3 will first compare it with I1, then I3 is less than I1, so I3 was swapped between I2 and I1, so I2, I3, I1, and then I3 will again compare it with I2, and since I3 is less than I2, so it will be now I3, I2, and I. So there are two swaps and there are two comparisons. And if we look at the fourth number, it will be three comparisons and three swaps. And if we go like this, in the one, it will be, there are, first step it is 0, the second step it is 1, in the third step, it is 2 and 2. Fourth step, it is 3 and 3. So in the n step, it will be n minus 1 and n minus. So the total number of comparisons are 0 plus 1 plus 2 and 3 to till n minus 1, which is this formula. And these are asymptotically, you can say it is n square. Okay, so to find, to get the sorted array, if the array's length is n, then you can find it in the n square time. So approximately n square time. So in the worst case, which we are saying that 4, 3, 2, 1, 1, that will be, if you put this, plug this n equals to 4 here, it will be 4 minus 1, and 4 minus 2 divided by 2, it will be, uh, where is my error here? Oh, sorry, it should not be n minus 2, my bad. It should be n minus 1 plus 1, which is n into n minus 1 by 2. So it will be not 4 minus 2, it will be 4. And this should be reduced to 2. So 3 into 2, which is 6, which we have found it. And now if you look at the insertion sort, it has an interesting property that till now, whenever you introduce the next card, the fourth card, if you look at till three cards, it will be in sorted array till that case. Like in this case, if we look at the first card which we have given 3 and 4, it will be 3 and 4. If we give the, sorry, this is the second card, and if we give it third card, it will be 2, 3, 4. And before giving the fourth card, the array of 2, 3, 4 itself is sorted because it's in the increasing order 2 and 3 and 4. And before giving the card 2, it was still sorted at 3 and 4. So before giving the next new card, it was before that it is still sorted. So if I give my ith card in the n array, so till I minus 1 cards, it is a sorted array. So it builds a sorted sub list on the left, and the right side is still chaos because we don't know which card is coming to us. So is this clear? Is this insertion sort is clear, or are there any doubts in insertion sort? Okay, if there are no doubts, then we can go ahead and see what is selection sorted. So selection sort is, now you can see the whole array in this case. Before you can't able to see the whole array, you are seeing just the second number. But in this case, you can see all the whole array. And now you have to sort this. So we'll sort it like, you will find the minimum of all those numbers. You can scan the whole array, find the minimum, and you'll find the minimum. Like in this array, we can see that the 10 is minimum. The result is 10. And then we will swap between 10 and 29. So the array now becomes 10, 29, 14, 37. So till 10, this is sorted. And then you will find the minimum of 29, 14, 37, and 30. And the smallest is again 13. So we'll swap 13 and 29. So this is now 10, 13, 14, 37, and 29. And then you will find, so this till now this is sorted. And you will find minimum of 14, 37, and 29, which is 14. And it is still here, so you don't need to swap. So now the array is sorted till this, and then you will find the minimum of 37 and 29. It will be 29, and you swap between 37 and 29, and this will be the sorted array. Again, we have to find the minimum of the number of comparisons in these cases. Okay, so the main question is, in how many comparisons we can find the minimum. So if we look at the 29 number, we will start from here. We will fix our minimum to 29. Then we will look at the second number, that is 10. So we know that 10 is less than 29. So we'll fix our minimum to now 10. Then we will look at 10 and 14. So 14 is greater than 10. So no need to change your minimum. And then we will go to 37. So again 37 is greater than 10. So no need to change the minimum. And then we will say 13 is greater than 10. So no need to change the minimum. So it will be the minimum is 10. So the number of comparison it took you, it's 1, 2, 3, and 4. So there are 4 comparisons you have to take. And the swap was just between 10 and 29. So the number of swap is just 1. If we look at this case, now you have to find the minimum of this. So first you fix your minimum to 29. Then you will see that 14 is less than 29. So you'll change your minimum to 14. Then since 37 is greater than 14, so your minimum is still 14. And then you see that 13 is less than 14. So now your minimum is changed to 30. Now again, how many comparisons it took you? It is 1, 2, and 3. Sorry, someone is saying something? Okay, so the number of comparison it takes you is 3. So comparisons is 3, and swap is again between 13 and 29. So just one swap. And if you look at here, take your minimum to 14. Since 37 is greater than 14, so your minimum is still 14. And 29 is greater than 14, so your minimum is still 14. So it takes you now these 2 comparisons, and since there was no swap, so comparison is 2 and the swap is 0 in this case. And in this case, you will pick your minimum to 37 and then check that 29 is less than 37. So your minimum is 29. And there is one swap of 37. So comparison is just 1 and the swap is 1. So if you look at number of comparisons are decreasing in just one number. Since here the length of your array is 1, 2, 3, 4, 5, the comparisons you need is 4. In this case, your length of arrays becomes 4. The number of comparisons you need is 3. And the length of your array now is sorted to 3. The number of comparisons you need 2. And 2, then the comparisons you need 1. So in the same way, if there are first round, there are n minus 1 comparisons. For the second round, n minus 2 is n minus 3, and in n minus 1, and in n 0. So the total number of comparisons is again the summation of these values, and it will be again n square. So in this selection sort also, the number of comparisons, the number of queries for the n array to sort, it still requires you n square queries. Like it's approximately n square, it's not exactly n square. So, is there any doubt in this case? Did you understand the selection sort and the insertion sort? If then we can move towards bubble sort, and then I will ask some questions regarding all these three and we'll look at them together. And the radix sort which ma'am presented, we can do it in the next week because she has given some analysis in the radius sort for the next week. Uh, if you have any doubts, you can ask in the Menti as well. I hope this is working Mentimeter. Okay, I see no doubts here. So let's move forward to bubble sort. So this is like you have to sort by looking at just the adjacent cell and not now the first cell or the whole array. You just have to sort it using the adjacent cell. So you will look at 5 and 3 and see that 3 is less than 5. So you will do put 3 first and then 5 later. So this will be 3, 5, 8, 4, and 6. And in this case, again, then you will look at 5 and 8. You'll see that 8 is larger than 5. So this will become 3, 5, 8, 4, 6. And then you will see 8 and 4. So it will be 4, 8, and 6. So 4 is smaller than 8. So you'll put it here. So this will be 3, 5, 4, 8. And then if you look at 8 and 6, it's smaller than 8. So this will be 3, 4, 5, 4, 6, 8. In this case, you can see that the largest number in the array will always go to the last end in pass 1. The number of comparisons, as you can see, first we compare 3 and 5, then 5 and 8, then 4 and 8, then 6 and 8. So number of comparison is just 4. And if we look at the same array and we will look at the past 2, so first we will compare 3 and 5. It will be 3 and 5 same. We don't need to change anything. Then we will look at 5 and 4. Since 4 is less than 5, so it will be 3, 4, 5. And we look at 5 and 6. Since 5 and 6 are sorted, so 3, 4, 5, 6, and 8. So the number of compare and 8 is, since is largest, we have found it in Parson. We don't need to compare it with 8. So the comparison is now 3. So again, if you see at the 5 number of length, first case you need 4 comparisons. In this past 2, you need 3 comparisons. And in the similar way, like the selection sort, it will be n minus 1, n minus 2, and 1. So 5, then 4. In the past 2, it will be 3, 2, 1. So it will be like n square again. So all these 3 sorted are like giving you a quadratic number of comparisons. So let's look at some example. Okay, let's look at this. So I give you this array, let's say 2, 3, 4, 1, and 9. And it is outputting me 1, 2, 3, 4, 9. So can you tell me which type of sort has applied to this? Like the second output is 1, 2, 3, 4, and 9. So is it insertion sort which is applied? Is it selection sort which is applied? Or is it bubble sort which is applied? So this is the question, like which sort is used here? Like just step 1. This is the initial is 2, 3, 4, and 1, 9. And it is outputting me 1, 2, 3, 4, and 9. Can you think of the sort? Which sort must have been applied here? So the step one is outputting this value. Any idea? So there are just three options: insertion, selection, or bubble sort. If you want to answer in the Mentimeter, you can just scan this QR and answer there. You can unmute yourself in the Zoom, or you can write your answers in the Zoom as well. Okay, I guess there are no answers. So look at let's go one by one and look at the bubble sort. What will bubble sort will do to this array? So it is 2, 3, 4, 1, 9. If this is the initial array, then what will bubble sort do? So first bubble sort will compare 2 and 3. It will be same 2 and 3. If there are no changes, so it will be 2, 3, 4, 1, 9 again. Then bubble sort will so uh, compare this 3 and 4. This is again sorted, so no need to do any changes here. And then it will compare 4 and 1, since 1 is less than 4. So it will be 2, 3, 1, 4, and 9. And then the bubble sort will compare this 4 and 9. And since there are no changes here, it will this. So by the bubble sort, after pass 1, it will be the array should look like this 2, 3, 1, 4, 9. But it is not matching with 1, 2, 3, 4, 9. So this is not the bubble sort. Okay. Let's look at insertion sort. So insertion sort, the cards are coming one by one. So there is first 2. Now the card has come 3. So after 3 is come, so if you compare with 2 and 3, 3 is larger than 2. So the insertion sort still will reply me this after step 1, which is also not matching with 1. But if we apply selection sort, so selection sort, if we look at this thing, so we will find the minimum of all this and then swap it with that number. So if we if we look at this, it will find me 1. So this is the searched one, and then we'll put this into the left hand side. So this will be the selection sort. Or maybe we can, since by the consistency, it should, like we are saying, it is swapping. So 2 will swap here and then 9 will come here. So by the consistency, 1 is swapped with 2 because 1 is the minimum. Now, can you tell me how many comparisons would have been required here to put 1 ahead in using the selection sort? Remember, this is a 5 length array. Like, how many comparisons do you need to find the minimum between 2, 3, 4, 1, and 9? Any idea? 4. Yeah, yeah, you are right. This will require 4 Number of comparisons, since the length of array is 5, so we are saying n minus 1, so 5 minus 1 is 4. Now this is the last question and then we will wrap up. So if my initial array is like this, 5, 1, 4, 2, 8, and I output my arrays like 1, 4, 2, 5, 8, so which sort has been applied here? And another thing is how many comparisons it would have done. Is it insertion sort, selection sort, or bubble sort? Let me show, I think, the array again. Uh, okay, Anya is saying bubble sort. Anyone else? Let me show the array again. And this is the output after round 1. And if you are done with finding the sort, can you tell how many comparisons also you need? Let me show the array. Let's give you 1 minute. And this is the last question, then we will wrap up. Okay, Anna is asking, is it 4? Okay, let's check whether it is first of all bubble sort or not. In I give you first card as 5, it itself is sorted. And then if I give you the card 1, so you know that 1 is less than 5. So the insertion sort will output you 1, 5, 4, 2, and 8. So this is not the output which we are looking for. So this is not the insertion sort. Now if we look at selection sort, it will find me the minimum of all these 5, 1, 4, 2, 8, and it will be 1, and the 1 will swap with 5. So it will again give me this. But this is again not the output. Now the option only left is bubble sort. So the array is given to me is 5, 1, 4, 2, 8. Let's first we will compare between 5 and 1, and it will be 1, 5 because 1 is less than 5. So this will be this output. And then we will compare between 5 and 4. This will give me 1, 4, 5 to 8. And then we will compare this 5 and 2 since 2 is less than 5. So it will be 1, 2, 5 and 8. And then we will compare 5 and 8. And since it is sorted, so it will give me the output as 1, 4, 2, 5 and 8. And this is what the output which is given here. So this is truly the bubble sort, and the number of comparisons is again since n minus 1, this length is n, and n minus 1 comparison, this is 4, and by looking this, it's also 1, 2, 3, and 4, so there are 4 comparisons. So try these type of questions with the check. This is bubble sort, selection sort, and insert sort. And okay, here also someone has given 4. Yeah, you are right. Okay, so by this we will wrap up, and let's meet you next time, same time, 5 p.m. Okay, thank you for joining. See you next time.